coefficients. And we could write it as NC0, NC1 up to NCn. Now based on this you have the multinomial theorem. So what does the multinomial theorem say? Multinomial theorem gives you the expansion of x1 plus x2 plus xk whole raised to n, and this is given by summation nc n1 n2 nk x1 raised to n1 x2 raised to n2 up to xk raised to nk. And this term nc n1 n2 nk can be written as n factorial by n1 factorial into n2 factorial into nk factorial. This is also called the multinomial coefficient. So I hope this is clear to you. We will do a few properties of binomial coefficients first. So I would start with the first property, that is NC0 plus NC1 up to NCn is 2 raised to n. This is the first property. To prove this, you just take x plus y raised to n. This is summation r taking value 0 to n, NCr x raised to n minus r y raised to r. If I were to put x equal to 1 and y equal to 1, I get 2 raised to n is summation r taking value 0 to n NCr. That would be NC0 plus NC1 up to NCn. So this is the first property. Now coming to the next property. The next property is you have to prove that NC0 minus NC1 plus NC2 up to minus 1 raised to n NCn equal to 0. So how would you prove this? So in this expansion we have x plus y whole raised to n is summation r taking value 0 to n NCr x raised to n minus r y raised to r. So put x as minus 1 and y as 1. So that would give you 0 equal to summation r taking value 0 to n NCr. So I get NC0 minus NC1 plus NC2 up to minus 1 raised to n. You get a minus 1 raised to r here. Minus 1 raised to n minus r here. So you get NC0 minus NC1 up to minus 1 raised to n NCn equal to 0. So these are two simple properties using the binomial theorem. Now coming to a simple problem, evaluate 12C53332. So if we were to use the property, this would be 12 factorial by 5 factorial into 3 factorial into 3 factorial into 2 factorial. And you could calculate this using your calculators. So I will leave the calculation to you. So we are using the property that NC R1, R2, R3 is n factorial by R1 factorial into R2 factorial into R3 factorial. Coming to the next question, find the sum of all the coefficients in the expansion of x1 plus x2 plus xk whole raised to n. So I would start with the binomial expansion. What is that? x1 plus x2 up to xk whole raised to n is summation over k nc n1 n2 nk, and then I have x1 raised to n1 up to xk raised to nk, x2 raised to n2, and so on. Now here put n1 equal to n2, put x1 equal to 1 equal to x2 equal to 1 up to xk equal to 1. So you get k raised to n would be summation over k nc n1 n2 nk, and that is the answer. Sum of all the coefficients is k raised to n. So in this case, sum of all the coefficients is k raised to n. We would go one step further. Find the sum of all the coefficients in the expansion of x plus y plus z plus w raised to 5. So this would be, what would this be? So using this formula here, k is 4 here because there are 4 terms here and n is 5. So using the above formula, the sum would be 4 raised to 5, k raised to n. That is 4 raised to 5. Okay, next question. Find the sum of all the coefficients in the expansion of x plus 2y minus 3z raised to 12. So here what we would do is, we would put x equal to 1, y equal to 1 and z equal to 1. So what do I get? 1 plus 2 minus 3 raised to 12 would be summation 12c n1 n2 n3. There are 3 terms here. 1 raised to n1, 2 raised to n2 and minus 3 raised to n3. So your right hand side, RHS, is the sum of all the coefficients, and that would be, what would that be? That would be, I'll use a different color here, raised to 12. So that would be 0 raised to 12. I would explain this step once more using a different ink. We will write the sum of all the coefficients as summation 12c n1 n2 n3, because there are 3 terms here, raised to x1 raised to n1. So 1 raised to n1, x2 raised to n2 is, you have 2 raised to n2, and x3 raised to n3 would be minus 3 raised to n3. n1 raised to, coming back to the formula, you have x1 raised to n1, x2 raised to n2. So you put y as 2 and z as minus 3. Put y as 2 and z as minus 3 here. So this would give you 1 y is 2 and z is minus 3. So this is the sum of all the coefficients, and that is, using the formula, it will be 1 plus 2 minus 3 raised to 12. So that would give you 0. So the sum of all the coefficients here is 0. I hope this sum is clear to you. Now coming to the next question. Find the coefficient of x raised to 12 in the expansion of x cubed into 1 minus 2x raised to 10. So first we would take the binomial expansion of 1 minus 2x raised to 10, and using the formula it is summation r taking value 0 to an NCR. So 10CR 1 raised to 10 minus r minus 2x raised to r. So that would give you summation r taking value 0 to n 10CR 1 raised to 10 minus r is 1 minus 2 raised to r x raised to r. Now we will multiply by x cubed here. So I will write x cubed into 1 minus 2x raised to 10 is summation r taking value 0 to n 10CR minus 2 raised to r x raised to r into x cubed. And what would be x raised to r into x cubed? That is x raised to 12. So it is summation r taking value 0 to n 10CR minus 2 raised to r x raised to r plus 3. Now we want to find the coefficient of x raised to 12. So I will put r plus 3 as 12 or r equal to 9. And now we will substitute that in this coefficient here. So your coefficient of x raised to 12 would be 10C9 minus 2 raised to 9. 10C9 is 10 and that is minus of 10 into 2 raised to 9. Because minus raised to an odd power is minus. So is this problem clear to you? Do let me know in your feedback. If you need help in any particular problem, find the coefficient of x, y, z square in the expansion of two x minus y minus z raised to 4. So by multinomial theorem, so when I use multinomial theorem, 2x minus y minus z raised to 4, you can write it as summation nc, n1, n2, n3. There are 3 terms here. I get 2x raised to n1, then I have minus y raised to n2 and minus z raised to n3. Now here I will put n1 as 1, n2 as 1 and n3 as 2. So when I would do that, what would you get here? Because you need to find the coefficient of x, y, z squared. So n1 is 1, n2